Okay, let's talk about periodic trends. We started them with the demos where you might be able to look at some reactivity rates in conjunction with lithium, magnesium, sodium, and calcium. But now we're going to really look at the differences in the periodic trends, and there are four main periodic trends. And the first one we're going to talk about is the atomic radius. The atomic radius, the definition is half the distance between adjacent nuclei in a crystal of the element. Basically, if you think of atoms as having like circular orbits, then and compounds as being more than one atom, the radius of one of those orbits is going to be your radius. If elements that occur as molecules, we're talking about diatomic molecules, and this is half the distance between the nuclei of identical atoms that are chemically bonded together. Again, if you think of the radius as in being a circle, the atomic radius is basically the radius of an element. The big trend is it decreases from left to right. So the radius gets smaller the closer you get to the halogens. This happens because if you think of an atom as having a positive center and electrons as being negative, when you have positive and negative, they're like magnets. They attract each other. So when you have more positive and more negative, they're going to go closer to each other and become smaller. And the group trend, so we talked about the period trend, but the group trend is increases from top to bottom. And that makes sense because the bottom just are bigger elements, and that's why they have larger atomic numbers. So visually, it goes left to right decreasing, top to bottom increasing. Or you could also, if you're just doing arrows towards increasing, which is, I always feel is easier, it increases this way and it increases that way. Those are the two arrows for atomic radius. It increases from right to left, it increases from top to bottom. So let's then talk about ionic radius. And the first thing you have to understand is an ion is an atom or bonded group of atoms that have an either positive or negative charge. This means they have either gained or lost an electron. Cat ions, think of cat ions as being cats because they're positive. They have lost an electron. So if you lose a negative, you become a positive. When you gain an electron, you create a negative anion, and then the orbital becomes larger. So the ionic radius is the atomic radius of an ion. So you're using the same definition as atomic radius, but we're applying it specifically to ions. And please remember, when ions are formed, we are always losing valence electrons or gaining valence electrons. So when we're looking at the trend, it increases from left to right because the left side, which is your column 1, column 2, your transition metals, which really kind of look the same, and column 13 are generally cations. Columns 15, 16, and 17 become anions. So the ones on the left-hand side are losing electrons, and the ones on the right-hand side are gaining. So if you're losing, you're getting smaller. If you're gaining, you're getting larger. And the group trend is the same. It increases from top to bottom because they're still bigger electrons. Bigger atoms. Here's a really interesting diagram. The gray is what they normally are, and then the colors is the difference when they're an ion. So if we're talking about increasing trends, the arrow goes this way for ionic radius. It increases from left to right, and it goes again down. It increases down the groups. These are your two increasing arrows for ionic radius. Now we're going to talk about ionization energy. The ionization energy, we were just talking about ions. It's the energy required to remove an electron from a gaseous atom. What does that actually mean? It's the energy required to take another electron. So it's how much money, basically you think of energy in terms of money, it's how much money you have to steal somebody else's electrons. So if you want to be a cation, you're going to have a low ionization energy because you do want to lose your electrons, your valence electrons. If you want to be an anion, you want to have a higher ionization energy because you don't want to lose your electrons. You want to electrons. So the first ionization energy is the energy required to remove the first electron from an atom. The trend is it increases left to right, and it increases up the periodic table. The first ionization energy decrease from top to bottom due to the valence electrons being further away. Basically, the bigger the element is, the less they have control over their valence electrons, so it's easier for people to get rid of them. So we're going to look at this, and then I'm going to explain why. So it increases up, it increases across, and a really nice one is going from francium to fluorine. Now this is an old periodic table. I had some of the older elements, but you can kind of see the trends. Now, I'm going to explain something to you if you're wondering why, and we're going to discuss it in a minute, but it's called the Octet Rule. And basically, the gold standard for whether gaining electrons, losing electrons, bonding, sharing, however they want to get to 8 valence electrons because 8 is great, and that is the Octet Rule. They want to gain, share, lose to get to 8. If we are looking at the like cations, if we're looking at like lithium, it's easier for lithium to lose their 1 and mimic helium by losing 1 than gain 7 and look like neon. It's easier for fluorine to steal 1 to look like neon than try to get rid of 7 to look like helium. Magnesium will lose 2 to look like neon. Chlorine is going to gain 1 to look like argon instead of losing 7. That's kind of why these over here lose and these over here gain. They're losing and gaining to try to become noble, to make that octet, and they do that in different ways. Cations lose, anions gain. So the Octet Rule is 8 is great. Atoms tend to gain, lose, or share electrons in order to get to 8 valence electrons. The definition of the Octet Rule is atoms tend to gain, lose, or share electrons in order to get to 8 valence electrons. Okay, we are going to talk about Octet Rule and electron configuration. Now, I have not explained electron configurations to you yet. We're going to be doing that in a unit or 2, but I do want to explain the Octet Rule very quickly in terms of electron configuration of what's actually happening. So when gaining or losing an electron, the electron configuration needs to change. I do not expect you at this moment to be able to do electron configurations. I'm just explaining to you how it works. So lithium is 1s2, 2s1. It's losing one electron right here. So it really looks like 1s2, 1 plus. The electron configuration of helium, which is a noble gas, is 1s2. And I'm sorry, I can't do subscripts here. So lithium mimics helium to become noble. If you're gaining an electron, you're going to add it. So fluorine is 1s2, 2s2, 2p6, 2p5. 5 plus 1 is 6. So what's 2 plus 6? It's 8. It is noble. So that's how it becomes noble. If I'm looking at my periodic table, neon is next one. And it is neon's electron configuration, 1s2, 2s2, 2p6. So if you look at the one that fluorine gained or got by gaining a valence electron, it mimics, so fluorine mimics neon to become noble. So you can either gain or lose different amounts of electrons to mimic noble gases so that you can also pretend you're noble. That's the end game. Now, if we're going to talk about the next big trend, or the final trend actually, it's electronegativity. Electronegativity, it indicates the relative ability of an element to attract electrons into a chemical bond. It increases as you move left to right. It decreases as you move down a group. In fact, it's the exact same trending arrows as ionization energy, but for the very different reason. If you want to gain electrons, you're going to have higher electronegativity. If you want to lose electrons, you're going to have lower electronegativity because you don't want other electrons to come to you. So if we're going to be looking, it goes, I'm going to show you the trends in a minute, but the lowest is francium and the highest is fluorine. That's just the way it works. Here's a nice visual of all the periodic trends and another explanation of the Octet Rule. And I'm doing the arrows towards increasing. So the pink is the atomic radius. It increases from right to left and increases from top to bottom. If I'm looking at ionic radius, it still increases from top to bottom, but it increases from left to right. Ionization energy and electronegativity are two different reasoning for the trends. They mean different things, but the trends are the same. That's why there's one set of arrows for ionization energy and electronegativity. Its lowest is down here. It goes bottom to top, kind of cross diagonally up to fluorine, and then left to right. And remember, the Octet Rule is electrons tend to lose, gain, or share their valence electrons to get to 8 valence electrons or noble gas formation. And finally, for what we're going to be discussing today, here is a nice 4 square of the big definitions and the trends. So this is atomic radius. Here's the definition, half the distance between adjacent nuclei in a crystal of the element. Here is a written definition of the trend, and here's those Y's we discussed. Here's ionization energy. Here's the definition. Here's the cation information. Here's your anion information. Here's your definition, here's your trend, and then again, here's your why. I've been discussing the whys all along, but here's a nice foursquare of all that information in one piece. Electronegativity and ionization energy, your trends, your least and most, and your whys down here. That is the big information on periodic trends. Any questions?